Hi, everyone. Everyone can hear me okay? Great. Thanks, everyone, for sticking around. I know these sessions can get a little long at times, but we've had a very engaging set of presentations to start. Hopefully, I can continue the trend. Oh, not so close. Over here. Is this better? Okay. So, our presentation is going to vary a little bit from the presentations you've seen so far, mainly because we are looking not just at submetering, but also a holistic approach involving energy conservation at a particular building. This is a very specific case study regarding a building that we were working on last year into this year and ongoing from there. So hopefully you guys can enjoy it. The first half of the presentation is going to focus on the energy reduction plan. So for those of you out there who are hardcore metering people only, you can take a nap during that half of the presentation. And then the second half, I'll get a little bit more into the weeds with the submetering architecture, some of the issues that we ran into at the building, some of the issues that we run into in general at existing buildings when you're trying to retrofit systems. And then I'll give a little update where we are now and where we're planning to go from there. So just really quickly about CodeGreen. We are an energy and sustainability consulting firm. We've been around since 2005. Got our start doing a lot of LEED building certifications for a lot of customers. We were definitely pioneers of that within the New York City region. We have since expanded to umbrellas that include corporate reporting, energy efficiency, metering, energy management, energy reporting, et cetera. We are at our core a consulting company, so we do have a wide breadth of services that we offer, and we also have a wide breadth of talent within our team. We have a staff of about 35 people, about half of them engineers, half of them sustainability professionals. Here's a little bit of our client list. We work primarily with commercial office buildings, Class A commercial office buildings in New York City, buildings that are interested in sort of trying to take a building to the next level when it comes to sustainability and energy performance. So it's definitely not something we take for granted. Just some general metrics about CodeGreen and the work that we've been able to do. We do a tremendous amount of work in New York City and across the country. So a little about this building. So this is a building out in New Jersey called Senwood Office Tower. Originally built in 1987. My first experience with this building was actually the first time I met this client. But the client that we were working with, who recently took over property management of it, also has their offices within this building. They've been with the building since the early 90s, and they've seen what I like to call a building that we classify as a time capsule building, a building that, the world is changing around it, technology is changing, systems are changing, but this building, with their investment style, was focused very much on how can I minimize my costs, how can I minimize my investments to keep a building running. This is going to work for a few years really well, but over time, systems, as we all know, end up in a place where you don't want them to be. This is true with HVAC, it's true with metering, also true with lighting. So when you're looking at this building as an energy efficiency company, you're drooling because there's a lot of opportunity and a lot of low-hanging fruit. Running through the mechanical systems really quickly, it's a 100% electric building, which, I hate to see anywhere north of New Jersey. It's all resistance heating, which makes me gag a little bit more. The system was outdoor air controlled. It's an old system, Kace system, built as a company out of New Jersey that has since gone out of business. Did a very good job creating very low-cost heating control systems. So, when a project's being V'd during design, this is the system that a lot of buildings in New Jersey ended up using, but it is pretty blind to what's actually happening inside the building itself because it's only based on outside air. So that was a huge immediate opportunity that was identified at this and other buildings that we saw with this client. In terms of cooling systems, you have one package AC unit on each floor, which I'll show you a little later, a little diagram I put together that shows how it is laid out in general. They do have 2-speed fans. At a minimum, they have a discharge air temperature reset, which is better than nothing, I guess, when it comes to a reset. Also, free cooling coils within the system, which was something that the building itself had a lot of issues with over the entire course of the building operation. Most floors were CAV, but tenants, as they've been fitting out their floors, always had the option of going to VAV, so it was a combination when we got to the building. About the only more modern component of this building that was in place is the cooling tower system, which I show there. That was working relatively well, but still hooked up to a condenser loop that has 3-way valves and no VFDs on the pumps. So even there was plenty of opportunity. In terms of lighting systems, I won't spend too much time on this other than to show one of my engineers, Yuta, enjoying his first metal halide bulb. He's in the audience here. The lighting in general was a hybrid technology of electric resistance heaters and light bulbs, aka incandescents, T12 lighting, a lot of lights in general throughout the building that were no-brainers in terms of switch outs. In terms of the metering system at the building, the metering system was original to the building. The infrastructure was original. Utilized power line communication, so there was no communication wiring anywhere throughout the building. The big difficulty from our standpoint when we're trying to retrofit these systems is not necessarily the existing communication or existing hardware. It's this third bullet here, no labels in the electric panels. And when I say no labels, I mean no labels. Completely blank little panel schedules in there. It's sitting there, but it's not filled out at all. Just sort of taunting us as we try to understand exactly where the loads are going in this building. You can see this was the drawing we received, which was back in the good old drafting days of drawings, and poorly scanned probably several times over before we received it. So it was a tough starting point. Solid core CTs is another thing that when you're retrofitting a system, when you're moving loads around, can be a major impediment to what we were trying to do, especially considering the signal, which I'll get into a little bit later. Whenever you have a commercial office building that is multi-tenant floors, I think a couple of the other presenters, Karen and Ann, both sort of mentioned multi-tenant office spaces are one of the main drivers of metering in buildings because you have to be able to bill your tenants. But especially with multi-tenant floors, if you're not being proactive about your system 5-10 years down the line after spaces have shifted, you're going to have a metering system that is not billing anyone properly in the building. That was the case in this building, as I'll get into a little bit later. But it is something, it's very, very difficult, even for a very proactive staff at a building, to stay on top of tenant electric fit outs. A supplemental unit gets installed, it gets put on a house panel. No one's there to oversee the process. These are the sort of things that happen a lot in commercial office. So there's the existing case going into the energy reduction plan. I mentioned before the client we're working with, Atlantic Realty Development Corporation. They had recently taken over property management. They knew they wanted to make major investments into the building. They didn't know exactly where they wanted to make their investments. As a consulting firm, it's sort of right in our wheelhouse to try and find them the best path forward with regards to incentives that are available, in addition to just most cost-effective approach. So the program that we landed on for them, which was really a round peg in a round hole, I guess you would say, it's a perfect fit for them. They have, for those who are not familiar with the program, it is an incentive program to try and incentivize energy efficiency. Instead of being prescriptive about dollars per fixture or dollars per ton of installed equipment, it's actually trying to base its incentive on actual energy reduced at the building. Because of that, it's a little bit more overhead than your typical rebate program, so you do have to build energy models as part of it. The Rebate itself is split into two different components. You get one rebate based off of the projected energy savings of all your measures. You get another rebate based off of actual M&V in the building, which tied it in with the metering work that we were doing concurrently at the building. Developing an energy model, especially for an existing building, is a art as much as it is a science, especially getting into more complicated systems, which I'll touch on in a moment. The lighting upgrades I will not bore you with. They're essentially switching out to LEDs throughout the building, occupancy sensors in restrooms, utility areas, bi-level fixtures in the stairwells, all sort of standard stuff. The one thing I will say is the client going into this project had a very bad impression of LEDs. We were able to pilot some more modern LEDs, which I'm sure everyone in the room knows have come a long way over the past 5 years, and prove out that the light quality that they were getting was not only as good as what they had, but better, much more cool light as well. Beyond that, you do with LEDs still need to be careful around HID lighting, very high wattage lamps. You may not get quite the lumen output that you're looking for, but the technology is progressing. We did have to pilot a couple of different fixtures before we found one that gave appropriate foot candles where they needed to be for those spaces. In terms of other upgrades that we recommended, so this was just sort of a laundry list of items to identify the building. Clearly, package AC unit upgrades is something they already wanted to do, and it just made sense for them. Putting VFDs on the supply fans, another complete no-brainer. We also looked at demand-controlled ventilation. This was something that, just looking quickly at this layout, you could see there's a dedicated outside air system delivering air to each floor with modulating dampers on each floor. Tying in CO2 control on each floor was a more affordable possibility than it is with a lot of arrangements. So it made sense for us to identify that. The condenser loop I mentioned briefly before, all three-way valves now, switching that system over to two-way valves in addition to putting VFDs on the condenser pumps was another easy decision for them. Water side economizer, it had actually been taken out of a lot of the package AC units that were existing in the building. So there was a aversion by the O&M staff of the building to be using them. But we certainly wanted to evaluate it to see if it made sense at this building. Unfortunately, this plenum for the outside air system, not big enough to do air side economizing, which is the clear first direction you want to go with that type of system. Beyond that, going from pneumatic to DDC, upgrading their electric heat from outdoor air control to thermostat control, and then a personal pet peeve of mine, as I mentioned earlier, electric resistance heat is the worst. It's easy to install, but you end up paying for it for a very long time over the course of building operation. Anything that we could do to try and offset electric resistance heat with natural gas space heating was going to be a net benefit for the building, so we did want to evaluate that. Concept design was a very interesting process. Going through working with the MEP, we were luckily involved very early on with the design at this building. It's not usually the case with buildings we work with. We're usually a little too late to make design changes. So we're able to get some things implemented that otherwise would not be part of the original design. We looked at DCV versus ERV, which is an important thing to model relative to each other because your ERV is going to save energy based on the amount of ventilation you have in your building. DCV is going to limit the total amount of ventilation in your building. So implementing one sort of mitigates the savings of the other. They still both save a certain amount, and so we were able to run what-if scenarios to essentially evaluate what made the most sense for them regards to both of those. Free cooling, also looking at the additional pressure drop across the fan, especially in buildings that have very long operating hours and the fan's running overnight. You may offset a lot of your free cooling water side economizer savings just with increased fan energy usage. And so that's another thing that we took into consideration. And also when you're working on a real MEP project like this, you're going to see a lot of practical limitations, size of the room and stuff like that we had to work our way through. This is what we finally nailed down as our metrics and the rebate they were able to obtain. So we're showing 33% savings overall at the building. The total incentive amounts around $236,000 that they're going to get post-construction. They've already done a lot of the construction. They still have some left to go. And then after a year of M&V, which we'll really be able to leverage the metering system for, they should be able to get another incentive as big, if not bigger than that. So, you know, a $1.8 million investment with a $500,000 rebate is really going to push down your payback period and lead you to a project that may otherwise not be implemented. So getting into the sub-metering now a little bit. You know, I like to show this picture. It's sort of a rat nest of wires here. You have solid core CTs that have what look like auto extension connectors. You would use those in a car, not necessarily in a electric panel. Not that I don't see it a good amount. Exposed wire there, high voltage wire that was somewhat exposed. You know, the sort of panel that really makes you cringe when you look at it. And you certainly don't want to be dealing with a system like this live. Solid core CTs have the added challenge of, especially when a panel is busy like this, you need the ability to either cut power, pull off each of those, you know, pull out the wires, rewire them all in without your donuts installed. It's a very difficult, cost-intensive, labor-intensive thing to do. Whenever we approach a system like this, we do not have a specific vendor that we work with. We try to stay vendor agnostic. There are certainly vendors that are better than other vendors, and we work with them more. But whenever we're approaching a building like this, we want to take what is the best plan for you and what's going to give you the best plan moving forward. In the case of solid core CTs, our experience with them is unless you have a CT that's pretty close to electric fault and you have a lot of heat generation near it, it's going to stay relatively consistent in terms of its calibration. It is, you know, a solid state piece of electronics at the end of the day. We knew the output from this system was something that our meters we were planning to install did not accept 0 to 100 milliamp output. So we wanted to try and find a new solution that could either leverage the existing CTs or find a way to switch them out more cost effectively. We knew the billing methodology. We had past bills from the building, but we certainly didn't put too much credibility into the accuracy of those bills. At no fault to the metering company, that's just, you know, the way that the property had been managed for 15 years. And that was the product of that. So there's two big technologies we implemented at this building, and I'll, you know, say sort of off the cuff that it was a 60-meter retrofit job, so 60 metering points throughout the building that we had to take over with a more open protocol system. Our typical installed cost for a meter is going to be $1,000 to $1,500 per meter, which I definitely hear all of the people who spoke before me when they're talking about how metering is always much more expensive than you expect it to be. Sometimes through creative solutions like this, you can minimize cost. So this was a building, it was a 60-meter install job that we did for about $60K. So we were very happy with the all-in cost there being, and that's installed, the system. So the two technologies we used, multi-channel meters, they've been around for a while, but they're getting better and better and a lot cheaper. This is the idea of using a single voltage connection to feed multiple loads. We used Dent Instruments PowerScout 24, which can measure up to 8 three-phase loads with one electric room on each floor at this building. It made a lot of sense to implement one multi-channel meter on each floor and replace up to 8 existing meters with that single meter. It's not only cheaper because it's one piece of hardware, but it's also cheaper because you only have to worry about one voltage connection for that system. The other big technology that we looked into for this building. We actually had this device designed by a company called Solid State Instruments. If you work in metering and you don't know Solid State Instruments, they're fantastic. Great shop to work with. They worked with us on a device that would essentially take in the signal from the existing solid core CTs and output a signal that our meters could read properly. Okay, good. The entire design costs for this, the engineering costs and the costs for the units themselves to translate those signals were paid for by the savings associated with not having to buy new CTs, not even looking at labor. So that was definitely an appealing prospect for us. You can see a couple of our engineers here testing out one of these systems to make sure, we ended up installing our own meter on the same load to make sure that unit we were using gave us accurate results. We did surveys of the electric rooms to try and understand what was going on at the building. We took very poor quality metering drawing and tried to digitize that, which our property manager definitely appreciated. We also did what we like to call soft commissioning of the system, which is more of a coverage test than it is a test of the meter accuracy. So this is, if you think a meter is metering a certain space and you know everything within that space, is there a way to sort of estimate to see if you're within the right ballpark of usage? So we go through, this is a process that we developed. We go through, we inventory all of the equipment at the building, printers, computers, plug loads, lights, everything that you typically find within a tenant space. And from that, you try to extrapolate out, okay, if it's a well-run space, how much energy is it going to use? If it's a poorly run space, how much energy is it going to use? And from that, try and determine how accurate are these existing meters. We found about 60% of the existing meters were giving us coverage issues. So almost order of magnitude values off of what we would expect them to be if it was metered properly. Because of that, we were able to leverage this system to provide better estimated bills for the client. And the allocations themselves are usually trickier than they look. Trying to do floor-by-floor allocations, tenant-by-tenant allocations, whole building allocations, common area usage, it gets complicated. I'll leave it at that. There we go. This is what we ended up with on one of the floors in terms of an allocation. And moving forward, a lot of the work's already been completed. We're planning, they're actually installing the AC units over the weekends, starting last weekend. They rig them up using the bottom of the elevator cab, which I thought was kind of cool. So other than the top floor, they're able to use the elevator shaft to bring the AC units up. And then beyond that, our plan, because of the M&V savings associated with this project, is to really dive deep into individual meters. These are 2 AC units. You could see this AC unit's turning itself off overnight. This unit's staying on year-round. We don't necessarily know why that is. Well, we do know why it is. It's different tenant constraints, but oftentimes systems like this are things where you can trim, in addition to commissioning of the systems themselves. I will say, this is before we're installing the AC units and the ERV. This is the savings we're already showing at this building, 2014 versus 2015. Which is saving them about $154,000 a year, weather normalized, for the geeks in the audience who like regression plots. There you go. And so I think, it's very promising now. It's only going to improve, and we're very excited about the work in general. So thanks, everybody.